Hello and welcome back to my stream for OneClass. Here at OneClass, what we're doing here is we are offering free live lessons in particularly for secondary school mathematics and chemistry. Again, my name is Joey. I'm going to be your Algebra 1 teacher for today's session. And just a little bit of background about me. Again, I'm currently a teacher candidate at York University. I'm currently in the intermediate senior division, which means that qualifies me to teach high school chemistry and science as well as music. However, I am pursuing my senior math teachable in the near future as well. So that's a little bit of background about me. Love math and love chemistry. So here at OneClass, what it is we're offering free kind of lessons for students who wish to kind of catch up on their work, or for students who want to get ahead in their work as well. So that's kind of what we do here as well. And I'm hoping that you find these lessons very much useful. And what you can do is you can always go towards and chat with me as well while this lesson is going on. Feel free to ask me questions about material that we cover today, or if you have any questions yourself, you can feel free to bring those up and I'll try to answer them for you as well. So without further ado, let's begin our lesson for today. So what we have today is, again, we talked about this concept of distributive property combining like terms last week. So last session. So what we're going to do is but let's just do one problem here. And let's pick here 24. And this is just a review of what we did of last session. This is 24. And what we have here is 24 is 10 minus 5 times 9n minus 9, I believe. And what we're going to do is, and how will we approach this problem? Just a little review of our lesson last session. So what we do here is we apply Pemdas, right? And what that is we're gonna do distributive property first because we're multiplying first, right? And you'll see an outside bracket here, inside bracket here. So what we're gonna do is we're gonna distribute this 5 to the first term and then distribute the 5 to the second term here. So what we have here is we have 10 minus 5 times 9 here is 45, and then with the end and as well, 5 times this negative 5 times negative 9 here is positive 45. And then what we're left here is we wanted to collect like terms, right? In this case, I see these constants are like terms as well. The n does not have another like term here, so I'm gonna combine these like constants. So 10 here plus 45 equals 55 in this case, and then we have just negative 45 as negative 45n, and we're left with negative 45n. So our answer here is 55 minus 45n. So again, we're very good at distributive property at this point. So what we're going to do is we are going to move on and do some that's just a review of distributive property in like terms. What we're going to do is we're going to move on to equations. So one-step equations. So how would we solve one-step equations? So when we talk about equation, it's different than an algebraic expression. Remember, algebraic expression is anything that it can be like, n minus 5, for example, as this term here is an algebraic expression. But when we talk about equations, it has to have an equal sign. It has two sides, where it has a left side and a right side. So if I did n minus 5 equals 5, for example, I have this here is a equation. And how would I do this equation? How do I define an equation? Well, I define it because a key feature of an equation has an equal sign, right? This do some blue. This equal sign here it equals something, right? The word equal is in the word equation. So in an equation, I have two sides. I have this left side, so left side here, and I have a right side as well, and then as well as an equal sign. And what I'm doing with equations, what I'm going to do is I'm usually solving each equation. So how would I solve this equation? This is n minus 5 equals 5. So when I'm talking about solving equations, I'm very much always talking about solving, or I'm solving for the variable. In this case, the variable here is n, right? I'm solving for the variable. And what does it mean by when I'm solving for the variable? It's usually the variable equals some type of number. So in this case, n equals some type of number, and what we can do is we can solve this equation, right? So how will we solve these equations? Sorry about that. n minus 5 equals 5. How do we solve this equation? Well, in these steps, what we want to do is we want to isolate the variable. And these are rules. I'm going to do this in red because these are rules for equations. Rules for solving equations. So what I'm going to do is step 1 would be isolate the variable. And then what I'm going to do too is I'm going to have to move stuff around. I might have to usually move the constants. I might have to move the variable itself, but I need to move move constants so that and this isolating the variable, means that we have to move stuff. So we're going to move constants or numbers or something like that to get that. And how would I move constants? What do I mean by move constants? What I'm going to do is I'm going to have to do either the reverse operation of each side. So I'm going to reverse operations. And what I'm talking about when I talk about reversing operations is addition becomes subtraction and multiplication becomes a division. So adding to subtract, and this goes backwards as well. Adding to subtract, and also multiply goes and then divide. So these are the operations we're looking at. If we're adding something, we need to subtract something. If we're multiplying, we need to divide, and vice versa for both of them. So reverse operations, and what we do is simply just solve the equation, and then that's step 3 here. Step 3 is solve for unknown. And sometimes step 2 might take a bit long time. Sometimes it's a one step, hence why we call it a one-step equation. There's some that are multiple steps, but we basically repeat kind of this step repeats till we isolate the variable. So let's do a sample problem, and let's do every other one. So let's do the left column here. So how would we isolate these variables? So let's do number 1. Number 1 here is 26 equals 8 plus, and this is a v sign, plus v. So how we solve for this equation? Again, we have, this is the left side, so we say ls is the left side, this is the rs, and then we right side, and we have the equal sign here. So we know that this here is indeed an equation. So we know here this is an equation. And what we're going to do is we're going to, again, how do we isolate the variable? That's the first step. We have to isolate the variable. We isolate the variable. We see our variable here is v. We want to isolate this variable. Remember, this here is our variable. What we have to do is isolate the variable. So how would we do that? What we want to do is we want to do the reverse operation to get rid of this 8. We want to isolate. Sorry, I get a drink of water actually. We want to isolate this variable. To get the variable on one side. So we want to isolate the variable to get it onto one side. So I want v to be left alone. So how would I leave v alone? Well, I need to get rid of this 8 here, right? This positive 8. So if I want to get rid of the positive 8 in this case, what I'm going to have to do is I'm going to have to do the reverse operation. So I'll have 26 on. So I still have 26 on. I'm not touching the left side, but what I'm going to do is what I have to do is I'm going to have to move this 8 towards the other side. And how would I move it? I'm going to have to subtract both sides by 8. So subtract 8 on the left side, and then equals 8 plus v, and then I'm going to subtract 8 by both sides. So you see how when I subtract 8 from both sides, again, I'm kind of manipulating this equation. I'm subtracting 8 by both sides. And how I can do that is I can only do that because I'm doing things to both sides. Every time you do an operation on one side, you need to do the exact operation onto the other side. That's why I can do this operation here. So again, 26 minus 8 here equals, this here equals 16, right? No, 18, sorry, 18. I can't do math. 26 minus 8 here is 18. And this equals, so again, 8 plus, and I'm gathering like terms now. 8 plus minus 8 is 8 minus 8, right? This here becomes 0, so I can cross those out, and I'm left with this just v, right? So now I know that v equals 18, and then I've solved my equation in this case. I've solved for my unknown, right? Because now I know my unknown. I know that v, in this case, equals 18. And what we can do is we can check our work, right? We can actually always sub this variable back into the equation. So how we do it, we do 26 equals, this is 8, and we know now v equals 18, right? So v equals 18, and then we just have to simply just check, this is a check, right? We're simply just checking our work, let's check. And then we're doing 18 plus 8 obviously equals 26. If both sides equal the same number, we know our answer is correct. So maybe let's check mark here. 26 equals 26. We've checked our work. We are good with this equation. So again, my answer here is v equals 18. So that's our answer here. And this is just a check to make sure our variable is correct. Again, this is a very, very important concept because solving equations is what we're going to do every time and time again. So this stuff again never changes, and it won't go old quickly. So I'm doing number 3 here, and we'll move a bit faster because I know first many of you this is a review. Okay, we have our left side and right side. We have our variable. This is b, our letter. So what do we have to do to both sides? What we're going to do is we are going to do the reverse operation to get the isolate this variable. But in this case, we have plus 15. I want to get it to this side, which means I have to subtract 15 from both sides. So let's do that. So we're doing 15 plus b, and then I'm going to subtract 15 from this side, and then subtract 15 from the other side. Again, 15 minus 15 here, this cancels out to 0. So I'm left with just b here. b equals 23 minus 15 in this case equals 8, right? So again, b equals 8 will be my final answer. Again, I can always check my answer. Again, this is optional. 15 plus, I can sub b back into the equation here. b equals 8 in this case equals 23. 15 plus 8 obviously equals 23. So 23 equals 23. I usually write something called left side equals right side. So everything in my left side equals my right side, which means this is a check. So I know for a fact that b equals 8 is my correct answer. So once we get this down, what we can do is we can actually start what we can do is we can start skipping steps. And what do you mean by skipping steps here? And I'll show you. So this is m plus 4 equals negative 12, right? So again, what we do with skipping steps, or when we get used to this and when we're getting good at math, what we do is we tend to do 2 steps at once. And how do we do that? What we're doing is, well, I know for a fact that m is my variable, and I know for a fact that I have to get rid of this plus 4. I have to move it to the other side to get rid of this. So what I would do is how I do it is I'm going to see this term, and what I'm going to do is I'm going to draw a little arrow, and I'm going to place it here. And when I move things across the equal sign, you can think of it as it's going to do the reverse operation. So now m is isolated. I have negative 12 here, but instead of plus 4, it's going to go over to the other side and it's going to be minus 4. So again, how I did the question, in reality what we're doing is we're just subtracting 4 from both sides. We have m plus 4 minus 4 equals negative 4 plus 4, right? But I know for a fact that plus 4 minus 4 equals 0. So I'm just getting rid of this step, and then I'm jumping towards this step here. So that's what I mean when I'm doing 2 steps at once. So again, I have m equals negative 12 minus 4. Again, negative 12 minus 4 here, you know, from subtracting negative numbers, negative 12 minus 4 here is equals to negative 16, right? So that's going to be our answer for number 5. Again, we can always check our work. Sub this 16 back for m. So get m here equals 16 plus 4 equals 12. Negative 16 plus 4, obviously, sorry, this is negative 12. Negative 16 plus 4 here equals negative 12, which means the answer is correct here, right? So m equals negative 16 will be our answer for number 5. So again, we're gonna start to move faster because I know a lot of you viewers at home know this already. So I'm gonna move a bit faster. I'll do a couple more, and then let's move on to 2-step equations. So let's do number 7. Again, m minus 9 equals negative 13. Actually, maybe I'll do a multiplication one. So let's do 11. 11 is, negative 104 equals 8x, right? So in this case, my variable is x here, and I want to get rid of this 8, right? Again, this 8 here is multiplied by this x. Remember, everything, if it's stuck together like this is implied that it's multiplied, right? So what I'm going to have to do is I'm going to have to do the reverse operation, right? So again, if I want to move this 8 to the other side, to the other side. What I'm going to do is I'm going to have to, instead of the reverse operation of multiply, is indeed divide, right? So I'm going to have to divide both sides by 8, right? Equals 8x divided by 8, right? And now I know that these 8's cancel out, so I'm going to, because 8 divided by 8 is just simply 1, so I'm left with x on one side, and then negative 104 divided by 8 would equal, let's see, negative 104 divided by 8 would equal negative 13, right? So x here in this case would equal negative 13. And again, I can always check my work. This is a check. I can do negative 104 equals, and then what's 8 times negative 13 in this case? 8 times negative 13 is indeed negative 104. So this here is my answer for number 11. So again, negative 104, so left side equals right side, which means check. So that means that x equals negative 13. So again, we can also start skipping steps here. What I would do is, if you get fast at this, instead of doing this step here, what we can do is we can start doing immediately from this step. I can go negative 104 over 8 equals x, right? And I'm doing this, and then this can also lead into this as well, right? I'm just simply dividing both sides by 8, but I know that 8x over 8 equals 1, right? So this cancels out, and I'm left with just this on the left side. So again, that's what you can do once you start getting faster and faster at solving equations. So let's do 13. And then we'll see if we can do a couple here. I don't know if they're harder. Maybe a fraction one, and then maybe we'll move on to two-step equations, because one-step equations are pretty easy. Negative 6 equals b over 18. And again, this b here is the variable. I want to get rid of this 18, right? Again, b is right now is being divided by 18. So here's the process of division, right? So if I'm dividing, what I have to do is I need to do the reverse operation. In this case, the reverse operation would be multiply. So multiplying both sides by 18. So I can say here negative 6 here will be multiplied by 18 equals b over 18 is multiplied by 18, right? Again, these two can cancel out, so I'm left with b would have to equal, so b would have to equal, this is negative 6 times 18, so in this case, negative 6 times 18 would equal negative 108, and that will be my answer for b. And what I can do is I can always check, so my check here is negative 6 equals, b is negative 108 in this case, and divided by 18, you realize that negative 6 equals negative 6, left side equals right side, and then we are done, which means that my answer, I verified that my answer is indeed b equals negative 108. So let's do a couple more. There's only 30 questions, so let's do 2 more, and then we'll move on. Let's do the later ones. Let's do 25 and 27, and maybe I'll give you some time. I'll give you about maybe 3 minutes or 2 minutes to solve this on your own. And then you can write on the chat what you get for the answers, so we can kind of engage in that way. So 27 is this question here. Negative 17 equals x minus 15, and 27 is v over 7 equals 8. So maybe take 2 minutes, and let's see what you can do. And if you have the answers, maybe type them on the chat, and if not, I'll wait a couple of minutes, and then we can work on this together. So take a couple minutes, and we can do that before I go over this again and go and take up the answers with you. I'm just going to open up a new tab here. We might get to this. We'll see how it goes. Because it's only been like about 20 minutes. I'm hoping we can get through a lot of material today. Okay, so let's take this up. Let's do 25 first. I hope you kind of got to think about what our first step here is. So again, our x is our variable in this case. We have x equals negative 17 equals x minus 15, right? So again, if I want to get rid of this negative 15, I have to do the opposite operation. So instead of subtracting 15, I'm going to add 15 to both sides. So I'm going to have negative 17 plus 15 equals x, right? And again, negative 15 plus 15 implied here, these two cancel out, so I'm just left with x here. And what's negative 17 plus 15 here? It's simply positive 2, right? Again, we know this already. This is simply just positive 2. Or sorry, negative 2. Negative 2, my bad. X here is negative 2. 25? Yeah, 25 is negative 2. And again, we can check our answer. So again, we can do a little check here in blue. We can say negative 17 equals negative 2 minus 15. We know that negative 2 minus 15 here is negative 17. So left side equals right side. So this answer is correct. And then for 27, we have is v divided by 7 equals 8. If I want to get rid of this divide by 7, I would have to do the reverse operation. The reverse operation of division is multiplication, right? So I'm going to multiply both sides by 7. So v over 7 times 7 equals 8 times 7. And this, the 7s here cancel out, and I'm left with just v here. So v equals 8 times 7, which equals 56. And that will be my answer for number 27. We can always check and plug in 56 as v. 56 divided by 7 equals 8. We realize, yes, 6 divided by 7, it does equal 8. Left side equals right side, which means my equation here is correct, and we've solved for this correctly. So I hope the one-step equations are very, very clear to you. If you do have problems with that, again, I would go back to this problem and maybe work on a lot of these problems in your own time. But what we're going to do is we're going to move on to two-step equations. So again, what does that mean by two-step equations? So two-step equations are simply just an additional step. So it's not just simply one step like this part. We move one thing to the other side and we're done. In this case, we're going to have to move two things or do two operations to figure out our answer. So let's do number 1 together. We'll do every other one, but this really draws on the same concept as we explained from before. So this here is 6 equals a divided by 4 plus 2. So when we talk about this concept of solving equations, what we have to do is we can, when we're solving equations, we're actually going to, when we're isolating the variable, we're going to have to do the reverse of Pemdas. And when I say reverse of Pemdas, remember it was P-E-M-D-A-S, right? Pemdas, we're going to have to do SAD MEP. So this is only for when we're isolating. So when we're isolating variables, we would have to use the reverse operation. So I'm going to delete this, but what that means is I'm going to have to do there's S here. I'm going to have to do addition, subtraction. I'm going to have to do those operations first, and then we're doing multiplication, division, and then exponents, and then parentheses. So that's what we're going to have to do. We do them in reverse order. So what does that mean? So it means that with this equation here, 6 equals a divided by 4. This is not a 9, actually. This looks like a 9 here. It's actually an a. So a divided by 4 plus 2, what we're going to have to do is we're going to have to do the reverse Pemdas. So what we're doing is we are doing addition, subtraction first. So in this case, we're going to want to get rid of this addition sign because we want to isolate this variable, right? My a here is the variable here. So what I want to do is I want to get rid of this positive 2 first. So if I want to get rid of the positive 2, I need to take the reverse operation. So there would be minus 2, right? So we take that to the other side. So 6 minus 2 equals a divided by 4, and then plus 2 minus 2 just equals 0 in this case, right? So that's fine. What's 6 minus 2? 6 minus 2 here is 4 equals a divided by 4 in this case. And then what we're going to have to do is we are going to have to solve for a, right? And how do we solve for a? We're going to have to do the reverse operation, right? We want to get rid of this divide by 4 here. So if we want to get rid of division, we have to multiply. That's the reverse operation. So I have to multiply both sides by 4. So 4 times 4 here. And the a divided by 4 times 4 simply just equals a, right? So again, a divided, we're going to get rid of this fraction here. And I'm just left with a here. And then what's 4 times 4? It's simply 16. So a here equals 16. And we can do a little check with the exact same thing as we did before. What we can do is we can sub in a for 16. So we do 6 equals, this is 16 divided by 4 plus 2. 6, and then we're going to, when we check, we have to do the actual order for Pemdas, right? So we're doing division first. So 16 divided by 4 is 4 plus 2. 4 plus 2 equals 6. So what it means, left side equals right side, which means my answer is indeed correct. So a equals 16. So again, these are two-step equations now. So we're doing the reverse operation probably twice before we get to the final answer. So let's do 3, and maybe take a minute to do this yourself at home if you're watching. I don't think I see anything in the chat, but if you want to chime in and give me the answer or walk me through your thought process, you can do that. I'll give you about 30 seconds to kind of visualize this, and then we'll take it up together. All right. So I hope you have enough time to figure that out. What we're doing, again, we have this, our variable here is x. And what we're going to have to do is we're going to have to do, again, reverse of Pemdas to isolate for our variable, right? So, which means that we're doing addition and subtraction first. So you see it subtract 7 here. What I want to do is I want to move this to the other side, right? If I move this to the other side, I'm going to have to add both sides by 7, right? So I'm left with 9x equals, remember, negative 7 plus 7 cancels out. I have negative 7 plus 7 here, right? And negative 7 plus 7 turns out to be 0, right? So that's fine. And now, how do I get rid of this 9 here? I have this operation is multiply, which means I'm going to have to divide both sides by 9, right? So if I do 9x divided by 9 equals 0 divided by 9. Again, 9x divided by 9 cancel out to simply just x here. And 0 divided by 9 is obviously 0, right? So I have 0 is my answer for this. And again, I can check my answer. I have 9, I'm going to sub x for 0, right? So I'm subbing this back into the equation. 9 times 0 minus 7 equals negative 7. 9 times 0, I'm doing now the actual order of Pemdas. So I'm doing multiplication first. 9 times 0 is 0, minus 7 equals negative 7. Negative 7 equals negative 7, obviously, in this case. And left side equals right side, which means my answer is correct, which x equals 0 is indeed the correct answer. So that's good. So again, these are two-step equations, right? And we're going to actually work towards multi-step. So this looks very, very daunting, but we're going to, hopefully by the end of this video, we're going to be able to work towards multi-step problems. So again, let's go and let's do every other one. I want to do one with division, actually. So maybe I'll scroll down. Let's do these 4, 17 to 23. So I'm going to do 17. This is n plus 5 divided by 16 equals minus 1, right? So how would we do this equation? Again, what might confuse some students in this case is when I say reverse order of operations, instead of Pemdas, we would do whatever addition, subtraction first, right? In this case, you can think of it as I actually can't do this. I can't get rid of this plus 5 first. And the reason why is because this entire operation or this algebraic expression here is divided by negative 16. Everything here is divided by negative 16, which means I can actually put a little brackets here to denote that, right? This entire thing is divided by negative 17, which means I actually have to do division first and then do my brackets, right? So I'm just rewriting those things for you. So if I want to get rid of this division, I'm going to have to do the reverse operation, which is multiplication. So I would have n plus 5 divided by 16 times negative 16 equals, and then I have negative 1 times negative 16, right? So I know these two things cancel out. So all I'm left with is n plus 5 here for my left side. And what's our right side here? Negative 1 times negative 16. Two negatives make a positive. So this is positive 16. Ooh. Positive 16, and then all I have to do is I have to get rid of this plus 5 now, right? If I wanted to get rid of this plus 5, I want to move it to the other side, but subtract both sides by 5, right? So I have 16 minus 5 in this case, which will equal 16 minus 5 here is 11. So n here equals 11, and I can again do a little check here and sub in 11 back into my equation. So again, I have here it's 11 plus 5 divided by negative 16 equals negative 1. 11 plus 5 here is 16 divided by negative 16 equals negative 1. Negative 1 equals negative 1, which means my left side equals right side. So again, this answer here is correct. So this here is 11, and that's going to be my correct answer for 17. So I'm going to see if we're going to move a bit faster because I do want to cover multi-step problems today within the next half an hour. So I'm going to do number 19. And this is negative 10 equals 10 times k minus 9. So how would I do this problem? So again, we're looking back at this topic of distributive property, right? This blue, this outside bracket is going to have to be evenly distributed to both terms. So then 10 has to multiply by k, and it has to multiply by negative 9. So I'm going to do that first before we solve for our variable, right? So 10 times k here is 10k simply, and 10 times, sorry, this k is bad, k, and then 10 times negative 9 here is negative 90. And now what we can do is we can isolate for our k here, right? So again, I see this negative 90, I want to get rid of it. I need to add both sides by 90, right? So as minus subtracting 90, I want to make it adding 90, right? I'm doing the reverse operation. So negative 10 plus 90 equals 10k. Negative 10 plus 90 here equals 80, right? So 80 would equal 10k. And then what I have to do is I have to get rid of this 10 here. It's beside this k. I don't like it. I want variables on one side only. So multiplication, and 10 times k is multiplication. I want to do the reverse operation, which is division. So I'm going to divide both sides by 10. So 80 divided by 10 is simply equals k. And now 80 divided by 10 obviously here equals 8. So 8 equals k will be my final answer. And again, I can always check my answer. So this is negative 10 equals 10 times 8 minus 9 here, because 8 here is k. And again, I'm using Pemdas, right? So again, I'm doing parentheses first. So again, 8 minus 9 here is negative 1. Negative 10 equals 10 times negative 1 here is negative 10. So left side indeed equals right side, which means k equals 8 is my correct answer for 19. And let's do 21 and 23 to finish off our two-step equations, and we're going to work on multi-step equations, which will probably take up the entire lesson after that, just because those are some of them have many steps that we have to go over before we can solve for our equation. So this is 21. So 9 plus 9n equals 9. So again, our first the order of operations, we're doing the reverse order, right? So I see a positive 9 on this left side. I want to get rid of it to the other side. So how to do that is I need to bring this 9 over to the right side. So I'm going to bring this 9 over to the right side. And by bringing it over from addition, it's going to become subtraction, right? So unless I'm left with 9n equals 9, and this is minus 9, right? 9n would equal 9 minus 9 here is 0. And then now I'm going to have to think about, okay, how do I get rid of this 9 here? It's multiplying by 9, which means I need to divide both sides by 9, right? So my left side here just is left with n, 0 divided by 9 in this case. Anything divided by 0. Sorry, anything. If my 0 is on top, again, 0 divided by 9 here is 0, right? So n equals 0 is my answer. I can check and say 9 plus 9 times n, which is 0, equals 9. Where this n goes here, right? And the n 9 plus 9 times 0 is 0 equals 9. 9 equals 9 is my, so I know left side equals right side, which means n is equals 0 is my correct answer in this case. And let's do last one to finish off two-step operations. I'll give you, again, for this one, I'll give you about 1 minute because I do need a drink of water. So I'll write this down for you, and then we can attempt it at home. So this is 8 plus b divided by negative 4 equals 5. So I have 8 plus b divided by negative 4 equals 5. Again, reverse order of Pemdas states that you have to do addition. I have to isolate for addition and subtraction first. So this positive 8 will then go to this side and become negative 8. So on this left side is b divided by negative 4 equals 5. This will be minus 8 now. So b divided by b over negative 4 equals 5 minus 8 here is negative 3. And then what I have to do is I have to now isolate for this b, right? So in order for me to do that, it's being divided by negative 4. I have to multiply both sides by negative 4. So my left side just becomes b. And then this negative 3 here, I'm going to have to multiply it by negative 4, right? So b, negative 3 times negative 4 in this case, 2 negatives make a positive. So I have b equals 12 is my answer. And I can always check. So I can do 8 plus, Oh, why do I keep doing that? Sorry. 8 plus b is 12 divided by negative 4 equals 5. 8 plus 12 divided by negative 4 here is minus 3, right? Minus 3 equals 5. 8 plus minus 3 indeed equals 5, and left side equals right side. Therefore, b equals 12 is my correct answer. So that's all we're going to do with two-step problems. What I wanted to do now is for the next 25 minutes, so I'm going to spend most of my majority of the time doing multi-step equations. As you can probably infer, multi-step equations are simply just two or more steps when we solve our equation. So again, we went from single step to multi-step, single step to two-step, and then now it is the multi-step. So get ready for that. And what we're going to do is we're going to I'll probably spend most of my time here, and we're probably going to end our lesson here in terms of multi-step equations. So let's do that before we move on to other equations. So let's do number 1. This is now multi-step equations. This is negative 20 equals negative 4x minus 6x. So how will we attempt this problem? So take a minute and let's see what our first step would be. Ooh, sorry. What is our first step in this equation? Well, let's see. I have negative 20 on the left side, so I can't really do much here. But then look at my right side. I have negative 4x minus 6x, right? So in this case, what I can do is I can gather like terms, right? And we talked about that concept last session. We're gathering like terms. We see negative 4x in this case is a like term, because they're both in terms of x, right? So what we can do is we can gather like terms first. So negative 20 stays here. And what's minus 4 minus 6, right? So in this case, it would be minus 10, right? Minus 4 minus 6 is negative 10. So negative 10, and I still have the x, right? And now what I can do is I can actually solve for my equation, right? I have here negative 20 equals minus 10x. Negative 10x, again, it's multiplication. I want to do the division, right? I want to do the opposite operation. So I'm going to divide both sides by negative 10. This here just equals x, right? And then now negative 20 divided by negative 10, these two negatives cancel out. So negative 20 divided by 10 here is 2. So x here equals 2. And again, I can check my answer. This is a check. And I can do negative 20 equals negative 4 times 2 minus 6 times 2, right? Again, I'm subbing in this 2 at 2 points. It equals here, and then it's also going to go here as well, and that's what I wrote here. So again, negative 20 equals negative 4 times 2 here is negative 8. Negative 6 times 2 is negative 12. Minus 8 minus 12 indeed equals negative 20. So left side equals right side, which means x here equals 2. So again, what we're doing is we're gathering like terms, we're taking distributive property, and then we're mixing it all together, and then we are solving multi-step equations. So I'm gonna do let's go from 5 and then downwards, because I feel like these ones are a bit trickier when we go toward this one. So let's start from 5 and let's kind of make our way down to 19. I think that's gonna be our goal for today. If we can do all of these problems here, 5 to 19. So 5 here states that 4m minus 4 equals 4m, right? So as you can see in this problem, I have variables on both sides, which is not a great thing. So if I want to isolate my variable, I need to be able to put variables on the same side. So let's do that. So how I'm gonna do that is I see 4m here and 4m here. I want to bring this to the other side, right? So if I want to bring this to the other side, I'm going to have to subtract both sides by negative 4m, right? So this just goes away. So I'm left with negative 4 equals, what's 4m minus 4m? In this case, 4m minus 4m each equals 0, right? So I have negative 4 equals 0. But you're like, okay, so this is kind of whack, negative 4 equals 0. That's not a that's not an equation. This doesn't exist. Which means if you ever come across this type of problem here, this means here I have no solution. So it means that, and what does that mean? It means no value of m would ever satisfy this equation. You can try any type of number in m and sub it into m here, but you're never going to get a solution because negative 4 is going to be on one side and 0 will be on the other side, which means therefore number 5, I have no solution. And sometimes we do get equations with no solutions. So this here is a no solution problem. So that's our answer for number 5. So this here is a bit tricky. A lot of students kind of stumble upon these solutions here. So let's do number 7. 5p minus 14 equals 8p plus 4. So again, take a minute and think about what do we need to do as our first step. So I have here, I see like terms I can gather, right? So let's gather some like terms. So I have 5p here and 8p here, and then I have my constants that are here and here, right? So let's do my variables first. I want my variables to be on one side. Let's pick the left side. So I want to move 8p to this left side here. So how do I do that? I'm going to have to subtract both sides. Right? I'm adding 8p to one side. I need to subtract both sides by 8p. So I'm going to have 5p minus 8p minus 14 equals 8p minus 8p obviously equals 0. So I'm left with here is 4, right? Now I can gather like terms here. 5p minus 8p here would equal negative 3p minus 14 equals 4. And then all I'm left here is I'm going to have to subtract, I see a subtraction of negative 14 here. I want to move this to the other side, right? So if I want to subtract, I'm going to do the opposite operation, which is add. So this is negative 3p equals 4, and then instead of subtracting, I'm going to add 14 to this side. So negative 3p would equal 4 plus 14 here equals 18. And then finally, what I'm going to have to do is, I see a negative 3p here, or negative 3. I'm going to have to divide both sides by negative 3, right? Because I see a multiply, negative 3 times p. I'm going to do the reverse operation and divide both sides by negative 3. So all I'm left with is p equals 18. I'm going to divide this side by negative 3, which means p here would equal 18 divided by negative 3 is negative 6. And that will be my answer for this is number 7. Sorry. And I can always do it. I can do a check, right? I think I'm only going to check this once. I'm not going to check my other answers, but I'm only going to, because it does get tedious. So here is 5 times negative 6 minus 14 equals 8 times negative 6 plus 4. So I'm subbing in this p here for this p here and this p here as well. 5 times 6 here, negative 6 here is minus 30. Minus 14 equals 8 times negative 6 is negative 48 plus 4. Negative 30 minus 14 equals negative 44. Negative 48 plus 4 also equals negative 44, which means left side equals right side. So p equals negative 6 is my correct answer. Again, I'm going to stop checking my answers just because it is just basically a different section, and I do want to kind of get to 19 here. So I'm going to work quickly because we only have about 15 minutes left. So this is number 9 here. So number 9 here, I have negative 8 equals, this is minus x minus 4, right? So how would I approach this problem? Again, this one's a bit tricky because this negative sign here plays a big difference. This negative sign, you can imagine here a negative 1 here, and then I'm going to have to distribute them to the stuff inside the brackets, right? So I'm left with negative 8 on the left side. This negative 1 times x is negative x, and this negative 1 times negative 4 here makes positive 4, right? So this negative has to be distributed into the brackets. So you got to make sure that happens here. Then I'm left with, I'm left with plus 4 on this side. I want to move it to the other side, so I'm going to have to subtract both sides by 4. Sorry, so minus 8 minus 4 equals minus x, and negative 8 minus 4 equals negative 12 equals minus x. And then I'm left here with what I'm going to have to do is I'm going to have to divide both sides by -1 in this case. Wait, hold up. Did I do something wrong? -1 is -8 equals -8 minus x plus 4, right? Did I copy the question wrong? So this is -6, negative x here. This is +4, which is... Oh, no, I wrote the question wrong. This is +4, sorry. Which means this here is minus. That's my bad. Which means if I'm doing -4, I'm going to have to add 4 to this side. Which means this here is not. This here is -8 plus 4 is -4 in this case. Sorry, I wrote the question wrong. And then I have an imaginary -1 on this side, right? I'm going to have to divide both sides by -1. So -4 divided by -1 equals x. And then -4 divided by -1 here simply just 4 equals x, right? So that's going to be my answer, or x equals 4. You can rewrite them both ways. X equals 4 will be my answer for this question. So sorry, I copied the question wrong, number 9. Apologize for that mistake. So I have 11 here. 11 is 14 equals negative, and then p minus 8, right? So again, this problem was very, very similar to the last problem where I have to do this distributive property with this negative. I'm going to distribute to this p and then distribute to this -8, right? So 14 here equals, I have -1 times p, which is simply just -p. -1 times -8 here equals +8, right? So -p plus 8. Now what I'm going to do is I'm going to have to move this 8 to the other side. So I'm going to subtract both sides by 8. So I have 14 minus 8, and then I'm left with this -p here. So 14 minus 8 here is 6 equals -p. And again, I want to get rid of this negative here, right? There's imaginary -1 here. So I'm going to divide both sides by -1, right? Because right now I have -1 times p. I need to do the reverse operation, which is division, right? So 6 divided by -1 equals p here. And then 6 divided by -1 equals -6 would equal p. And that will be my answer for number 11. All right, we're almost there. 4 more questions, and these are going to be a lot tougher than these other ones. So hopefully you can follow along at home and solve these equations with me as well. So -18 minus 6k equals here 6 times 1 plus 3k. Sorry, I didn't like that bracket. 1 plus 3k. So what can I do with this? Again, I do usually distributive property first, right? So again, I want to break these brackets apart. So I'm going to leave the left side for now, and then I'm going to do a distributive property between these things. So 6 times 1 and 6 times 3k here. So 6 times 1 here is 6, and then 6 times 3k here is positive 18k, right? So that's good. Now what we can do is we can gather like terms, right? And I'm gonna see variables. I see 6k, sorry. I see -6k, and I see positive 18k, and I see these constants here that can also be gathered. So let's do the variables. First, I'm going to put the variables to my left side in this case. So I'm going to move this 18 towards this side. I'm going to move something positive 18. If I'm adding 18, I need to subtract 18 from this other side, right? So I'm going to subtract both sides by 18k, right? So -6k minus 18k equals, and this I'm just left here with 6 in this case. So -18 equals, -18, and then -6k minus 18k. So -6 minus 18 would equal -24k equals 6. And then now I want to bring this number here back to the right side. Right? I want to gather my constants together. So I'm going to, instead of -18, I'm going to add 18 to both sides, right? So -24k equals 6 plus 18, right? So it's awesome. So it's plus 18 here. And then what I'm going to have to do is I'm going to, what's 6 plus 18? 6 plus 18 here is actually 24. So here is 24, which is nice. We have 24 on both sides. So now all we have to do is our final step here is that we have to, since I'm multiplying k and -24 together, I need to divide both sides by -24. So I'm left with here with k. I have 24 divided by -24. Again, this here, k would have to equal -1. So in this case, k here equals -1. And again, we could go back and check it, and if I put -1 as k and as both k's here, I will get left side equals right side. So if you want to check that, you can do that yourself. and make sure that that's correct here. And I'm 100% sure that that's correct. So that's here is question 13. I'm going to see if I can do 15, 17, and 19 before our video ends for today. So this is 15. So this is 15 here is 2 times 4x minus 3 minus 8 equals 4 plus 2x. So I see a lot of things we can do here. So again, what we want to do first is break down the brackets, right? We want to expand this, use distributive property and expand the brackets here. So again, 2 times 4x here is 8x. 2 times negative 3 here is minus 6. And then I'm left with negative 8 here equals 4 plus 2x. What's my next step here? I see x's on one side and x's on the other side. And then I see constants, right? I see all of these constants here. So what I'm going to do is I'm going to do the variables first. So I want to move the variables. I'm going to move it to the left side here. So I'm going to bring this positive to this left side. So if I want to bring something over, I need to do the reverse operation. So plus 2x becomes minus 2x. So here is 8x minus 2x minus 6 minus 8 equals 4. So 8x minus 2x here is 6x. And then minus 6 minus 8 equals 4. Now, what you could choose to do two different things here. You could choose to do this operation first and then bring it to the other side, or you can just bring everything to the other side. Personally, I'd rather do the operation first. So this is 6x minus 6 minus 18 will equal negative 14. This equals 4 here. Now I can bring this negative 14 to the other side, right? So I have 6x here. I have negative 14 on one side, which means I'm going to add both sides by 14. So 4 plus 14. 6x would equal 4 plus 14 here is 18 in this in this scenario. Actually, always in all scenarios is 18. And then I have 6 times x. I'm going to do the opposite operation, which means I'm going to divide both sides by 6. So I'm left with x here, 18 divided by 6 here, x here, 18 divided by 6 obviously equals 3. And that will be my answer for this question here, x equals 3. So we did that's number 15. So we have 2 more questions left, and then we'll be done with multi-step equations. We're not technically done because this stuff always comes back, but that's just a little done for today. Let's say done for today. So we have negative 1 plus 7x here, bracket negative 6, bracket negative 7 minus x equals 36. So I see a lot of brackets. So what we're going to have to do, let's look at this problem. We're going to have to, again, use distributive property and expand these, right? I have negative imaginary 1 here. I'm going to distribute this here, distribute this here. I have negative 6 distributing here and distributing here. So let's do all those steps in one step. So negative 1 times 1 here is negative 1. Negative 1 times negative 7 here is negative 7x. Negative 6 times negative 7 here is positive 42. Negative 6 times negative x here is positive 6x. This will equal 36, right? And this is nice because my variables are already on the same side. So I can just simply gather like terms, right? Negative 7x and 6x I can gather. So let's do that first before I do my constants. So negative 1. So what's minus x plus 6x? And this will equal just simply minus x, right? So minus x plus this is 42 equals 36. And now what I can do is I can collect these constant terms, right? These terms here, negative 1 and 42, I can collect those terms. So I'm left with, I still have negative x here, but negative 1 plus 42 equals 41, right? 40 equals 41, I believe. Let me just, negative 1 plus 42 is 41. Sorry, I have brain fart here. Plus is equal to 41 equals 36, right? And now our equation becomes much easier to solve, right? All I'm going to have to do is I'm going to have to move this positive 41 to the other side to make it negative 41. So I'm subtracting both sides by 41. So minus x equals 36 minus 41. Minus x equals 36 minus 41 equals negative 5. And then my last step here is I have to get rid of this minus sign in front of the x, right? If I want to get rid of that, I have negative 1 times x, which means I'm going to have to divide both sides by negative 1. So I'm left here with x equals negative 5 divided by negative 1. So x here simply equals negative 5 divided by 1. These minuses cancel out. 5 divided by 1 is 5. So x equals 5 will be our answer after all of this work. Here, x would equal 5. All right, last question, and we are done for today. This is 19. Actually, let's do 20. 20 seems more challenging. Let's challenge us for our last question of the day. This is negative 5 times 1 minus 5x plus 5 times negative 8x minus 2 equals negative 4x minus 8x. This is a very long equation. Wow. So I see a lot of brackets. I can break those down first, but I also see like terms here, right? So let's do both steps at once. Let's collect like terms, or sorry, let's distribute these guys first, and then let's also collect these two like terms in one step. So I have negative 5 times 1 here is negative 5. Negative 5 times negative 5x here is positive 25x. Positive 5 times negative x here is negative 40x. Positive 5 times negative 2 is negative 10. And that equals, what's minus 4x minus 8x? This will equal negative 12x, right? So again, I can see that I can gather like terms immediately here. So I have 25x and negative 40x. So maybe I'll do this operation first before I move it to the other side, because I still have this x here, right? I still have to work with this x. So we do this operation first. So negative 5 plus, so positive 25 minus 40x, so 25 minus 40 equals negative 15x. This is minus 10 equals negative 12x. Now what we can do, we can choose to either move 15 to the other side first. So maybe I'll do that first. So I'm left with negative 5 minus 10 equals, if I have negative 15x here, if I move it to the other side, I'm going to add both sides by 15x. So negative 12x plus 15x. So negative 5 minus 10 here equals negative 12x plus 15x in this scenario is 3x. I'm left with, let's work on this left side now. I have negative 5 minus 10. We are almost there. Negative 5 minus 10 here equals negative 15 equals 3x. And now we're in the home stretch of things. All we have to do is we have to isolate this x value. If I have 3 times x, I'm going to have to divide both sides by x, do the opposite operation. So negative 15 divided by 3 equals x here. Negative 15 divided by 3 equals negative 5. Negative 5 equals x will be our final answer for 20. So again, this is a this was a very, very tedious thing. In this question, I'm going to break this down before as a review of what we did today, because we do have about 3 minutes left. So again, what we did first was we did distributive property first. I'll write this down. So we did actually I'll do some blue, red, sorry. We did distributive property first. And then, but simultaneously or at the same time, we actually also gather like terms, right? So in this case, like terms. So that brought us to here. And then what we did was, and then we actually did more gathering of terms. We gather like terms here as well. We gather like terms in this case to get us from here to here. So that was 25 minus 40x would be negative 15x. And then all we're doing is and then what we did here was we moved this negative 15 to the other side to make it positive 15, right? So that's what we did from here to here. And then we gather like terms again. Gather like terms again. In this case, we gathered negative 20x plus 15x would give us 3x in this case. And then what we did was we actually kept gathering like terms. Negative 5 and negative 10 are like terms. They're just numbers, right? So we did this again, and we got negative 15. And then afterwards, what we did here was we did our one-step equation. Right? This is our now, we broke this down to our one-step equation where we just did the opposite. So multiplication becomes division, and then we solved our equation. Here, right? We solved the equation. So this monster of a problem became, we broke this down using distributive property. We gather like terms, and then we broke it back down to a one-step equation. And that's how we do multi-step equations. We want to start from a very, very big thing, and we want to start gathering like terms, maybe doing distributive property, start moving things around to get us to our answer in this case. So what we did today was we did one-step equations, we did two-step equations, we did multi-step equations. And what we're going to do for next lesson is we're going to start exploring some functions. And what we're going to start exploring, I'm going to drag this here. We're going to start exploring absolute value equations here, and then some radical equations. So there's easy and hard, easy and hard. We're obviously, because we love math, what we're going to do is we're going to obviously do the hard ones, and then we're going to do some proportion and some word problems. So that's going to be for next time. So again, thank you for tuning in to Algebra 1, and as always, have a great day.